everyone, and I'll go ahead and turn the mic over to our panelist, and I think we'll probably kick it off with Michael from a TigerGraph.
Thank you, Laura. Hello, everyone. This is Michael Shaler. I run partnerships at TigerGraph. One of our best partners is obviously Expero, and we're going to talk today about AML. And we're going to go deep on kind of how things are changing, kind of what the role of machine learning and graph and analytics and human in the loop, and then Scott's going to show us the art of the possible with the Tiger fraud solution. And I'm really excited because having both Graham and Scott will take us deep on kind of what the capabilities are, but also kind of what we can do to help all the various needs that come with anti-money laundering. So next slide, please. So we're going to talk about anti-money laundering in detail, but we want to make sure we have we zoom out a bit, or we pan to see it in context. Financial crimes have 10, 12 different variants that banks and other institutions need to be mindful of. And so money laundering is one part of it, fraud is another, cybercrime and sanctions and embargoes, these all fit together in the context of financial crime. But what makes anti-money laundering so very difficult is not just these three layers of money laundering: placement, layering, and integration. It's not even just the billions of dollars that banks and other institutions need to pay, but it's the difficulty of finding who the crime ring is. It's one thing to find mules. It's another thing entirely to find crime rings. And that's what we help do with our graph analytics platform and the solution that we're about to show you today. Next slide, please. So here's 5 different key considerations for anti-money laundering. First of all, it's a $1 trillion problem or more. In fact, the UN, those figures are, if I'm not mistaken, about 4 years old, and this is a train that hasn't slowed down. It's not just banks. That's a very, very important point here. It's retail, casinos, real estate, art, as in fine art, and human and drug trafficking, and terrorists and others are all part of these very complex network flows of capital and goods that are under the umbrella of anti-money laundering. In terms of sorry, not yet. Okay, so it's not just risk scoring. We need to understand connected behavior. And what that means is that, in order to understand those 3 layers of anti-money laundering: placement, layering, and integration, we also need to understand behavior that connects all of that. So it's not just risk scoring. Risk scoring is necessary, but not sufficient. And then taking that one step further, it's not enough just to know your customer. You need to know your customer's customer. You need to have a view of the ultimate beneficiary all the way back to the primary account owner, and you need to understand all the steps that connect that chain of attestation, but also chain of potential suspicious activities. And then finally, the solution is, it cannot just rely on humans. It's not enough to run this in a spreadsheet. It's not enough to run this in a relational database. You need to see it in context. You need to see it connected. You need to see it in terms of the graph analytics, the machine learning, the AI, to help investigators do even more, even better. Let's dig in further here, please. Next slide. When you think about what is, what the risk of not taking action, it's huge. It's billions of dollars, and in both of these cases, JPMC as well as HSBC, they both have really had to change how they approach anti-fraud and anti-money laundering. And so you can see that the net is that in 2020 the AML Act was passed. That's going to be the first of several legislative actions that regulators are going to be looking at in terms of how they're going to be having conversations with banks, casinos, retail operations. All of that is going to need to come under greater scrutiny and have greater tooling, because next slide, the criminals are getting better. They're getting smarter, they're going bigger, and they are able to do things that range from AML, then that becomes ransomware. The connection there is obviously cryptocurrencies and other mechanisms. So the summary is that we're seeing an acceleration of bad actors across networks, and we need to understand that in the context of connected behavior. Now, let's next slide, please. Let's talk about specific fraud use cases. And obviously, today we're going to focus on anti-money laundering, but that is, like I said in the first slide, that is in the context of financial crimes. And so, we see on the left a pretty substantial and meaningful list of business cases. And then we talk about how to do investigations with visualization and, the dependency and network pathing and routing. And we also need to do clustering and community detection. So we're running graph algorithms with machine learning together to create this view that comes out on the right with kind of what the patterns are for recommendations for investigators, doing the what if and planning and visibility. The predictive and analytics piece is really powerful, and what we can do together is extraordinary. Let's talk next slide. Let's talk a little bit more about what the AML legislation that just passed means. The codification of risk-based approaches includes machine learning and Boolean logic and graph algorithms. That increases accuracy, lowers false positives, and means that we can have more complete documentation and reports when these suspicious activities need to be elevated and investigated. In terms of modernizing it, SQL is not going to get the job done. You can't see all the way into a network of behavior with traditional SQL and flat file systems. You're going to see expanding enforcement, higher requirements for disclosure. You're going to have sharing, and we are working with both banks and regulators as well as other institutions to deliver this. And we want to make sure that we de-risk the entire process, increase accuracy, decrease false positives, and escalate and resolve investigations. Next slide, please. When we think about what are the drivers, there's obviously, in terms of business value, there's three big buckets: increase revenue, decrease costs, and mitigate risk. And we need to make money, save money, and protect money. What that translates into is that, there might be objectives around AML or fraud, cyber and migration to cloud, and material fraud detection as a way to protect money. And then you have the audit and regulatory compliance considerations go into that. In terms of the use cases, customer intervention, fraud rings, know your customer. IoT is important here because a lot of this involves not just financial instruments, but also physical goods. And then we also need to make sure we're smart about the analytics and compliance. And then again, prosecution is going to be important for different kinds of financial services institutions and others to be smart about how they're going to do that. Now, on the right, you can see who are the audiences and kind of who has what at stake here. And we're going to talk in a little bit more detail about some of our customer examples in a moment. But what I think is on the next slide, where this all goes is we see a layered approach to anti-money laundering in terms of understanding it from a graph perspective. We start with machine learning and deep learning. That gives us a 5% increase in accuracy and if you do it correctly, you're also going to see less false positives. Add graph and machine learning and insights and algorithms, that increases your accuracy another 6%, even better in some cases. And then we're using things like Louvain modularity as a graph algorithm to detect fraud and to detect AML. And then finally, with visualization techniques that Scott's going to be showing, we have the ability to do more with humans in the loop. So you can see an increase. If you stack that up, it's over 16% improvement to get started. And then from there, we get even better, and we can go further and help our customers do more to prevent financial crimes. How do we do that? Next slide. Gartner has been banging the drum about how graph relates to everything. We actually had at our recent conference, we had Brad Spears from JPMC talk about how graph relates to everything and reduces the number of hairballs they have to try and digest. The point here is, in the context of everything else going on, graph is one of the top trends for 2021 in terms of data and analytics. We're really excited to be here, and we want to help our customers do more and do more even more powerfully. Next slide. How does graph relate to everything? There are 6 kinds of graph analytics, and I'm not going to go through all of these, But finding an optimal path, that is clearly related to finding rings in a AML use case. Community, we want to identify group clusters, and we want to understand where the focus needs to be. In terms of centricity, we can identify who are the most important nodes, or what are the most important nodes. In terms of similarity, we can actually understand how to think about common patterns among behavior. And then we can also, based on that, we can also use leverage graph to do link prediction, saying here is a more likely use case for us understanding a financial crime ring in their next steps, and we can move ahead of them. This gives us a chance to move into a hunter posture rather than a passive posture. And then the last one, probably most relevant to what we're doing here with AML, is all about connectivity. Understanding the strength and weaknesses of connections, connected components, and connected entities with their relationships. Summary is we have 6 different ways to do graph analytics, and it's very powerful for anti-money laundering. Next slide, please. It's really exciting to see customers like Bank of America use graph analytics for credit card fraud. This is tens of terabytes of data. It supports complex investigations, real-time transaction ingest, and then it identifies fraud rings for further scrutiny to help the investigators. So in terms of business drivers, they had to replace their previous graph technology. They weren't seeing the kind of scale and performance that they needed. I mean, this is 10 years of data with 4 billion nodes and vertices. It's a large data set, as I say, tens of terabytes. But what we delivered within about 6 months is we were able to replace their legacy graph database. They were able to do more work with PageRank, which is obviously a very well-known graph algorithm, but also Louvain modularity for community detection, so they could identify likely credit card fraud. Summary is that they lowered TCO by 50%, saved millions, tens of millions of dollars, and they were able to deliver back to the bank a lot of value in a very, very short time. So it's really exciting to see such a breakthrough use case as Bank of America embrace graph technology. Now, what's interesting is they're also looking at how to accelerate that with FPGAs from Xilinx. So it'll be interesting to see where we all, where this all goes to deliver these goods and deliver these benefits in a very powerful way, very, very quickly. Next slide, please. Now we're going to talk about our AML use case at US Bank. It's important to put this in context that US Bank had to pay $600 million fine in the previous year, not just 2 to 4 million a year, but this one was a big one. And so they had urgency, and they knew the importance of this. They needed also not just to get into compliance, but they also needed, a very important requirement was to reduce the number of false positives. And so that way, they don't hinder good customers from doing what they expect with their money and with their financial plans. In terms of increasing the accuracy, they use graph connections to understand what were the non-obvious relationships between transactions, between network flows of financial instruments and other goods and services. And then finally, leveraging the graph analytics enabled them to go deep, leverage machine learning, and then automate the pattern detection behind that. So that we actually bolted into their existing NICE Actimize, Oracle, and other rules engines. We were able to add machine learning and analytics, and Graham's going to talk about this. I'm really excited about what he'll be sharing today. Again, it was a large, complex data set, and the benefits are that they're going to increase the accuracy. And we're only getting started, but we expect 10% as a starting point, where we expect to go maybe double that soon. They're going to be able to avoid fines, and they're also going to be able to reduce the process automation, or increase process automation and decrease costs over time. So this is really exciting to see customers do some important things. Next slide, please. I want to talk about TigerGraph and kind of how we were able to do this. So TigerGraph was founded in 2012. We were in stealth mode for 5 years. We're based in Silicon Valley. We are the only scalable graph database for the enterprise. We're magnitudes faster than our competition. We're foundational for AI and ML. We can do concurrent OLTP and OLAP workloads, which is so important in the AML context because you need to be able to deal with ongoing transactions in real time. How are we able to do that? We have the scale, the speed, and then we have the language for this as well. GSQL is graph structured query language. It's like SQL. Select star where works quite well, but you can do so much more than that, than just what SQL can do. We can do graph algorithms, like we said, Louvain, PageRank, etc. But we can also run that anywhere you need, on-prem, SaaS, in the cloud. And we're a global company. We're growing fast. We have great customers in all of these vertical markets. We've got some really, really strong investors, and apparently the analysts think we're pretty cool. Let's double click on Forrester for a second. Next slide, please. Forrester recognizes us as a leader in the Forrester Wave, which was completed at the end of last year. And just to double click on this one step further, next slide. We had a perfect score on scalability, performance, workloads, transactions, queries, data loading, and APIs. And we were the only one to have that kind of coverage, that kind of depth, and that kind of power. So we're an important part of the platform that is going to be part of an AML solution. But let's talk about what that looks like for customers in detail. Our solution focus, next slide, please, is all about increasing the accuracy, eliminating false positives, leveraging current technology. In other words, we don't need to rip out NICE Actimize or CyberSource. We can actually leverage what they do, and Scott will be showing what that looks like. We can not only decrease false positives, but we can increase speed and efficiency. And then we can adapt to changes. We can be smart about how this is all emerging, how this clustering changes over time. And then we can have a system that learns, adapts, and gets better over time as well. In terms of the architecture, next slide, we have a great kind of ability going from left to right, bringing in data from all of the source systems, whether that be relational databases or data lakes or data warehouses. We can bring that into the graph database platform, which includes a graph storage engine and a graph processing engine. We can run that anywhere, and then we can connect to all the consumption endpoints. And we're going to show one, we're going to highlight one today, which is the Tiger Fraud Toolkit. But that enables us also to plug into enterprise logic and enterprise applications and all the consumption endpoints. So we have the ability to support not just execs and planners, but also analysts and the IT teams that need to be able to support these initiatives. So the summary is that we have a very, very compelling platform. We've got the capabilities to help customers do extraordinary things. And now we're going to hand it over to Scott to talk about, next slide. Oh, I'm sorry, we're going to have Graham dig into the machine learning graph and human in the loop combination. And so Graham, over to you, please. Looking forward to hearing what you have to say today.
Thanks, Michael. Thanks for the great introduction, setting the stage there. As Michael mentioned, I'm going to walk through in a bit more detail, give you a peek behind the curtain about how the Tiger Fraud software works. I want to mention here that I'm going to show you this stuff from sort of 10,000-foot view. If you're interested to dig in more specifics and kind of see how the algorithms work, just reach out. My contact info is at the end of this webinar. So this is what the traditional data maturity curve looks like, and everyone on this call probably has seen this in one form or another, starting at the stage on the left-hand side where we are aggregating our data assets as a business, moving into the decision-making space assisted by analytics. So these are traditional analytics, like in the fraud detection world. These are level 1 analysts looking at transactional records, party records to understand where we have malevolent behavior. And on the right-hand side, which is what the Tiger Fraud software allows you to do right out of the box, is get into the augmented decision-making realm and the autonomous decision-making realm, where we're using the data automatically to help our analysts make decisions more accurately and with less burden. As Michael said, we're going to reduce false positives and we're going to increase accuracy. So there are 4 major tenets that underlie our software. Those tenets are monitoring of the systems. So this is now monitoring of analytics, not only traditional software monitoring. There is the deployment scenario where we get not only our internal analytics online rapidly and continuously, we also integrate your analytics that you have in-house into this single platform. So you can see everything alongside one another. The third tenet is active learning, which is to say that this platform, this software, has a feedback component that enables it to actually adaptively learn in real time as analysts interact with the software. And finally, and the key mechanism here to enable the active learning is the interpretability of the algorithms, explanatory reasoning that helps analysts understand why the software is making the decisions it's making and how those decisions affect your business. Let me jump into a bit of a detailed look about the architecture here. And this is more of like a data flow. Again, if you're interested in sort of specifics of any of these boxes, just reach out to us. At the top of the screen, we see a bunch of different data sources coming in. The beauty of using this graph-based data model that Michael was talking about earlier is that we can actually ingest a huge variety of data sources and have them exist in one sort of common book of record. Because of the way that the graph data is structured, you can then query across from, let's say, your internal transaction records out to something like a US Treasury blacklist of known malevolent or fraudulent actors. So all of that stuff is in the data structure. We then pipe that in the middle of the slide here, pipe that into a variety of scoring models. So these models could be everything from a very sophisticated deep learning model all the way down the line to systems you already have in place, like, for instance, business logic. Right? If you have a rules engine that's making decisions about which transactions or which parties should be flagged for your investigators, that stuff integrates seamlessly into the Tiger Fraud platform. And of course, I would be remiss if I didn't mention the graph analytics, and that's really the secret sauce here. Michael mentioned a few graph algorithms earlier, and I'll touch on a few more in a minute, but suffice it to say that there is no substitute for the sort of structure of your data, analyzing that structure, and that's what those graph algorithms do. All of those things are exposed at the bottom of the slide into the front end that Scott will show you a demo of in a few minutes, and are exposed alongside that explanatory reasoning I mentioned earlier, those explainable AI metrics, and the decisions that those investigators make. Again, you'll see a demo on this in a minute, are fed back into those models, into those algorithms, to make sure that the system gets better over time. And most importantly, it adapts to changes in fraudsters' behavior, because we know that static systems don't keep up. So that's how the whole system works together. Let me mention on the next slide a couple more graph-based algorithms. These are the core bases of the algorithms that are used in the graph processing scheme I mentioned on the last slide. Those are, as Michael mentioned earlier, related to a variety of things like clustering, similarity, pattern matching, centrality. These metrics, these measures of what's going on inside of your data are as I just said, the key to sort of upgrading the accuracy of your system and simultaneously decrease the number of erroneous recommendations that are served to investigators. And as an example of this, you could imagine a situation in where as you have new transactions streaming into your data set, those transactions are then associated by something like a community clustering algorithm into neighborhoods. Over time, what the system will find is that fraudsters, have, with similar behavioral patterns, tend to cluster together. So let's say a money laundering ring will tend naturally to cluster into a single group because they're exchanging financial transactions between the members of that ring. And when they are identified, when these algorithms, these clustering algorithms, put them in a neighborhood, that neighborhood necessarily has a higher percentage of fraudulent behavior. And that measurement, like how much percent of each neighborhood is fraudulent behavior, is a key metric in doing an up-leveled fraud analysis. You can't do that without the graph-based algorithms. That's just one example of many. And we see on the next slide here that there are indeed very many algorithms. We use all of these in the Tiger Fraud platform. We then combine those graph algorithms with the algos on the right-hand side, machine learning algorithms, to be able to adaptively score the behavioral conditions that are represented in the data that you house in the system. So let's jump forward one slide here and take a look at some behavioral recommendations, as I just mentioned. So these, as you can just click through all the animations on this slide, as we look through the panels in this slide, and again, I won't cover all this stuff in detail, we actually see the behavior that underlies the data. As I just mentioned on the last slide, what we're really looking for as fraud investigators, as actual human being fraud investigators, is not some risky flag, some single risk flag in our data. That's just not realistic, right? What we're really looking for is behavioral patterns. Like, for instance, panel number 1 on this slide. By way of example, what you are looking for as an investigator is this party, this company, had many of its agents, of its registered agents, conducting financial transactions with historically malevolently behaving individuals, right? That is an intuitive recognition of a behavior that underlies the data. And those types of behavioral recognitions are the ones that are, again, enabled using graph combined with machine learning. So let me show you what that looks like on the next slide. This is just a high-level look at the whole class of graph machine learning algorithms, but many of them do operate similarly, and they operate in this context. So what we have is a graph on the right-hand side that is teased out into its individual behavioral components. Again, that is through a variety of mechanisms. One of them is the clustering thing I mentioned earlier. We extract the ego graphs and the subgraphs from each one of those clusters, behavioral clusters, feed that into a machine learning algorithm as a feature vector, so-called feature vector in the machine learning world. And then we use a graph-based machine learning algorithm to make recommendations, to surface insights to the fraud investigators, right? And this, by the way, works in a wide variety of contexts. Like, I've mentioned anti-money laundering several times now, but the same is true. The same structure is true for transactional fraud detection, like credit card, retail fraud transaction, account breaching, organized criminal detection. These this architecture shown on the slide is appropriate for all of those types of fraud behavioral detection. And indeed, that's what you get out of the box with this Tiger Fraud software. Let me jump ahead here and just show you one example of money flowing through a particularly pretty graph structure you can see there in the middle of the slide. This is just an extract from a very large database, graph database. And we pulled this out because it does have such a nice typified circular pattern in this graph data structure. Highlighting this here to show you that you can design an algorithm based on the structure I showed in the last slide, and indeed we have that in Tiger Fraud, where it continuously looks for these types of ring-based behaviors and then outputs flags on the involved not only transactions but parties as well. So just wanted to point out that that beautiful sort of extract from a graph data structure. One more example on the next slide here is, and you saw a little collapsed version of this diagram a few slides ago. This is a very concisely clustered graph. So starting with the unstructured raw graph data structure on the left-hand side, after you perform the clustering on the neighborhood detection, it's also called, on this graph data structure, what you find are these really clear neighborhoods of behaviors. And if you have some way of scoring them, as I mentioned before, based on potentially known fraudulent behavior, or even just investigator going through and recognizing something, highlighting that back into the system, as Scott will show you in a little bit, you can then build up this notion of risk. And of course, this is done algorithmically in the TigerFraud software so that it is scored every time you log into the platform. And on the next slide, what we have is exactly that. We're showing an example of the recommendations there on the left-hand side. So this is just a stack rank scored list of transactions in this case. Again, the same structure works for any money laundering, account breaching, these things. It's just the list that you see on the UI is a different list, right? It would be parties instead of transactions in the AML case. And then, as you can see there, also important to recognize, yep, thank you. We have a feedback mechanism here, explainable AI mechanism here to be able to show you why that recommendation is being surfaced. And then on the upper right, you can see, was the system right or was it wrong? Accept or reject this recommendation. Digging deeper into the UI, you can actually see some explanatory reasoning based on graph structured information. And that is the grid, the heat map you see there on the lower right. These are connections to known malevolent behavior. And you can click through on there to navigate to those cases if you want to see the detail on what happened there historically. Now, once you've done that, as I mentioned earlier, you would probably like to tell the system, hey, that was a good recommendation, or no, it wasn't a good recommendation. But over time, what you want to be able to do is also tell the system why you were making that feedback, why you were telling it whether it was good or bad. And in this case, what we see here is a claim and a suite of recommendations, a suite of feedback rather, that allows the user to provide a judgment call back to the system. Those individual characteristics are fed, for the machine learning nerds in the crowd, are fed back into the features data set that's used to retrain a model, the actual recommendation model and the risk model autonomously, so automatic retraining. And then the system uses that new model version to make recommendations next time the user logs in. So it is a fully adaptive system. So to wrap it up, I just wanted to say that we're using explainable AI to power this fully adaptive system and increase visibility into your user base, your customers, the external parties that are doing business with your company. Let's say if you're a bank, in order to more accurately detect fraud, like in the AML case, the transactional retail case, account breaching, organized crime behavior, and to do so in a way that requires less burden on your financial crimes investigators too, by reducing those false positives. So that's it for me. I'm going to turn it over to Scott. Thanks, everybody.
All right. Well, we've kind of set the stage now. Michael did a good job that, fraud is out there where we're going here. And I think the next sort of section here is, we've heard the word TigerFraud. Most of you may know what TigerGraph is. TigerFraud is now the full stack solution. What that means is we now have multiple users in our touching, if you will, what Graham had just told us. That's a lot of technical, that's a lot of heavy lifting. However, it's designed to be very intuitive, very simple, and cover multiple users. So if you're an executive, perhaps you're in the business unit of anti-money laundering or cyber or credit card fraud, et cetera, how do you see your channel? How do you see your line of business? How do you see your alerts? Now we can run multiple versions of these. We can look at different kinds of investigations. Those investigations may cross those lines of business. So I may start something in cyber, may end up in credit card, and then finally maybe also linked to money laundering. the system that we'll see today has that capability. TigerGraph, the database, is uniquely capable, as Michael mentioned early on, for multiple security and containment, different alerts, etc. And then finally, at the bottom, we see TigerGraph Studio, which is now the other half of the equation. But as a solution, Tiger Fraud is designed with both sides. So there is a business component as well as a technical database component. Now, in this solution, you don't have to buy all the different modules that we'll see here in a minute, or you can just buy the database. But many of our customers are really wanting to be in finding the fraud and investigation business to go do that. So how does this solution work? What we see now is over on the left, we may have those multiple business units, like I mentioned. They now have their set of user interfaces and, more importantly, their own data. So although the KYC data may be the same, the investigations are different on a need-to-know basis. However, again, TigerGraph can uniquely combine that in sort of one systematic or federated data. So now what I can do is break down those silos. One of our customers' sort of use cases where they mentioned what was happening is the bad guys were hitting them in credit card fraud, they were hitting them in cyber, and they were in effect individualizing their view of the data so it looked like tens of thousands of dollars. When stepped back and looked across time, it was tens of millions of dollars, because the bad guys knew how that bank was actually segmenting and doing that. And that is now sort of the superpower of what the solution now, Tiger Fraud, is capable of doing. Here are a few of the modules. I'll be walking through these at a high level. But the point here is, again, mix and match. Your system, you may already use case management with Actimize or Oracle Mantis, or you may already have alerting that's custom built, et cetera. What we're defining and what Graham showed was that power of augmentation. Perhaps it's taking the graph and combining it with one of these modules and stepping it up a notch. They're also designed in such a way that, again, you can mix and match, or we can augment what you already have. Now, what does that demo look like? So lots of words, and let's get right to it. So in this case, our demonstration that we'll talk about is that dashboard. Now, many of our customers already have dashboards. So what I'm showing here is part of the Tiger Fraud solution. This dashboard can actually have the widgets that I'll show you, that core functionality that touches the graph, can actually sit inside of an iframe. That means that if you have Tableau or Power BI, or insert your own dashboard here, the functionality that we can sort of dive into here in a minute, all of that can sit connected in there. So we're capable of doing that. But in this case, what I want to see now is I have a couple of things going on. I have the ability to look at KPIs. So that information is located inside of TigerGraph. Those queries are nicely handled. And then we can also connect those to other source systems. So maybe some of these KPIs are coming from, again, Oracle or some other system as more of a mashup in the dashboard. And that's very easy to do. Now, the first thing we see are alerts. We see escalation. We see caseloads, right? We can also see how we can drill into those. We can look and query these kinds of information, but it's the connected data that Graham sort of mentioned to us that becomes so incredibly important. Now, Graham mentioned lots of capabilities and connections and algorithms. Those are typically manifested in this concept of an alert. And for those that are familiar with this, we can now go in and build what we call predicate alerts. These could potentially have Boolean logic in Graham's diagram, where we pull that from an existing system. Maybe that's a SQL system. Maybe that's your Actimize or whatever it may be. In this case, what I'd like to do is build a new alert. I want to show that items are coming in perhaps from high-risk countries. Now, I could pick anything in here. I could pick my own region, my own state, whatever that may be. In this case, any transaction that's coming in from Mexico, and I may now want to combine that with a TigerGraph algorithm. Well, the TigerGraph algorithm, as we select this here, maybe, as Graham mentioned, maybe there is a community connection to people that are already under investigation, or have a SAR, or other kinds of degrees of centrality and those other algorithms. But this business user is a super user. They want to use all of that really cool stuff that Graham talked about. And I want to know is there a similarity in the customer name or an account or party ID where they may have connection to a SAR. The second thing then is I could come down here and say, well, maybe I want to do transactions where they're sending or receiving, or perhaps now maybe I want to do more of a frequency one here, et cetera. But the point of this now is I can build up these what are called predicates with these kinds of things. And those trigger events. That triggers somebody wants to perhaps route this for a review or group those, and I can start to now diagnose those. Now, again, you may already have an alert system. We can augment our alert capability into existing ones, or in that case. But what's happened now is I've created that alert. Now what I can do, if I'm perhaps another level 2 or level 1 investigator, I can go look at those alerts, and they could be anything, right? So as Graham mentioned, those different kinds of things are triggering. Well, in this case, I see a SAR connection, and there are connections to existing SARs. That's a problem. And so as Graham showed in his diagram, what I'm able to do now is this alert perhaps has a connection to a SAR. Well, there are other alerts that perhaps have gone on that maybe no one took advance, never connected, or things have gone on. Well, that may be good or bad. That helps my investigation. But the other thing now is what's happened is it's been pre-curated inside of this particular alert. I can now choose to double click on this. I can go into an advanced search mode. And now I can say, well, maybe I want to go look at these. And then, aha, there is my person in red. So what I have now found in that sort of first stage is I really need to do something with this alert. I see workflow where I can potentially open or close this. There's that moment that Graham showed us where I can feed back and say, maybe I want to close this. Maybe in the future, I only want to see things that have a high risk score, et cetera. But that's our feedback loop. That's now our first journey. Now, the second thing that I can do is I can actually go in and look at a current or an investigation that's inside of a case. Now, what I can do over here is perhaps I want to see that sort of fully curated case. In this case, I'll open that. Now, what happens though is I am now looking at this full case ID. It already has everything curated for me. I have the ability to go in and do that. I can go look at that investigation now for this case. And what I see now are all the alerts, all of the people, the activity, those kinds of things. Those are all sort of set up for me inside of my screen. The second thing that I can do is perhaps now part of that idea of creating the SAR. So what's happened now is I've generated a SAR. I can actually pop that open. And what it's done now is it's built a little summary for me, and then it fills out the form for me. But what we've primarily done in this style of application is allow that basic sort of process flow from start to finish. And that's really what we're doing. The second sort of use case that we want to see in the tool is what we see now is typically a lower level investigation. And in this case, what I can do is I can go in and I can look at investigations that are already there. In this case, I can potentially see that I have searched already for Fran Farmington. I may actually want to go in and do some other kinds of searches in here. And what I can do now is I can go find other kinds of information. Now over here, I found another party. What I can do is simply grab that person. What has happened now is I've added that to an existing investigation over here. Now in this case, what I'd like to do is something that's tremendously interesting for investigators in the lower level. It's sort of the progression, if you will. In my first view here, what I see is where I started was on Fran Farmington. I can see in any part of this, as I can see in other places. I can double click on this, but what I've done now that's so incredibly interesting here for this investigator is you see here on this particular party, I can see that Fran Farmington has different sessions and different addresses. Well, there was an alert that actually transpired over here. And then finally it goes to another account. Well, what I can start to do now is I can start to see it over time. And if you look, what I have now is this ability to show this progression over time. So in my first view, I see that perhaps I'm watching Fran Farmington. And then in my second view, I see, aha, Fran now has a connection to a deeper transfer that's going on with another account. And then what's happened now is it's actually started to spawn out. And now what I can do is I can dig in this capability. And so I have actually found up here in an email with my final party is that this ring actually got much larger. Well, what I've done now is I've given that user that capability to go do those kinds of things. Now, again, I can zoom back in. I can actually hide things in here. I can hide those different kinds of things. So as an investigator now, I have that sort of ultimate control. Now, again, as that particular level 3 investigator, I may have different elements where things are brought to my attention. You noticed in the first dashboard, perhaps that level 1 person, they're pre-curated. This person now can actually go in and look at these different styles of communities. And then I can actually go add other kinds of things to my dashboard for what these are. And the point of this now is to allow that sort of super use for different styles of user. And that's really sort of what we're trying to do now in this Tiger Fraud solution, is give the investigators in different levels the right tools and combine that with that capability and the sophistication that Graham brought to us in sort of what he walked through in how we did it behind the scenes. So bring that extremely capable and graph technology, as Michael started out with, augment it now with machine learning in an extremely usable fashion. So again, I went through a lot of things very fast, but that's all part of now what's part of the Tiger Fraud solution. And what is this brought to you by? Well, the capability of doing that deep link pattern discovery in 2 or 3 ways, right? Both have the system find that for me, as you saw on the one screen, where it can be pre-curated. So let the average level 1 investigator see it and use it. Or as you saw in the level 3 investigator, dig deeply. The other element is don't get caught starting with something that's great, finding fraud, and then find that you can't scale. That's a pretty common thing that we find, is that very simply, you may start a POC and have that capability. That is the sort of the number one thing that we find from these customer and prospect, the POCs that we work on is, look, it looks good for 1 terabyte, but when I get to 20 terabytes, how does it handle? And the beauty of this now is this is designed to handle some of the largest problems in the world. Now, that doesn't mean that if you're a small customer and you don't have that kind of data, it just means that you can be assured now that we can handle even the largest of that. And then what you saw, what Graham showed, and then hopefully what you saw in my part of the demo, is that it's easy to see it, it's easy to recognize it, and then sort of the comfort of being able to go in and do that. Now, if you're in the machine learning group, how do you do that? We have those capabilities to go in and show that. So bringing it all together now is we have this capability to do investigation and alerts for that ease of use on the business side. We have the scale and performance on the back end and developer side. And then with our ecosystem, with machine learning and getting smarter and better over time, we're able to enhance that. And I think that's the core thing that many of our customers and prospects are telling us, is that the strength of this solution is the combination of all 3 of those. Now, the other element is we have a modular capability for developers, and then we have training so that we can train technical folks to perhaps extend this. That's another thing that we see in the development side is, what if I want to connect it to insert custom system here? And the answer is the Tiger Fraud system is designed to go do that. So what we want to do now is bringing it all together. What makes this so unique is that ability now to show that party and what I'd call the atomic capability, right? Everything starts at that atomic level. Show me wire transfers, show me all the transactions, the parties, everything, et cetera, and then show it to me over time, which now gets into my scalability. So if I actually want to look back at 5 years of fraud and see what has changed over time, that is a non-trivial capability. And that is something that we exceed in, is that capability to do that. And then do it in real time, right? Be able to run those machine learning algorithms, that clustering capability that Graham mentioned, to proactively intervene. We want to stop fraud, right? We don't want to go investigate all the fraud that has gone on. We need to be able to do that in line, in real time. And then finally, in our user or business side of the house, everything that I just mentioned, it has to be easy. It has to be explainable. It has to be sort of layered in such a way for 2 kinds, right? So we talked about pods of business users in different areas. So maybe the AML team, it has to be easy for them, but it needs to be equally easy for the cyber team. Then it needs to have that role-based access that perhaps maybe one of my investigations bleeds over, where I now need to share that information. So that capability to have security and role-based access. And then finally, the right user interface. Don't give persons that don't need the deep link analytic user interface unless they need it. And if they do, they need to have it. And so it's that capability of being able to set up for those personas in order that they can do their job more efficiently, et cetera. So where we started today was an incredible, flexible capability juxtaposed by what Michael laid out, which is now this capability to keep up that 2020 AML, the ability to codify. Hopefully you saw that today. That ability now to share that data in a secure environment. How to modernize. That's what this style of a system is capable of doing now, is bringing a higher order to the table, right? So what we believe, and we're very passionate about this, and please follow up with us after the webinar, is how can this kind of solution help with the AML Act? We believe that we hit almost every tenet that's behind that act, and we're excited to talk to you. So we also can do it in the cloud, and sort of wrapping it all up is this whole modular capability as well. So with that, I will bring it to a close, and Laura, throw it over to you for questions.
Super. Thank you guys for the presentations today. Just as a reminder, we do have a few minutes here for time for a few minutes of time for some questions. So if you have any, feel free to drop them in the Q&A box at the bottom of your screen and we'll run through them. There were a couple that came through to the panelists. Scott, since you just finished up, we'll start with you. They were asking, how did they get started?
So we have two flavors of what one is called a POT, where if we can sit with you and a handful of information, we're happy to do that at no charge. We can show you how that works with your data. The second version would be a more exhaustive version, and we're doing that today with some of our customers, where we're working with sort of a combination of synthetic and realistic data, where we're taking a little more time in working with several business units, and that usually takes anywhere from 4 to 6 weeks. So either one of those, we're happy to chat with.
Awesome. Thank you, Scott. Graham, there was one that came through during your talk. Let's see here. Can we integrate our existing ML fraud system in the software?
Yes, the answer is yes. It is actually, there's a couple different ways you can do it. And one is just by integrating what exists today. What you'll find is that that is seamless and easy. The other way, which you might find interesting, don't know who asked the question, but what you might find interesting is actually ingesting into your existing ML solution some of the graph-based information, the actual structural information from the graph. And we can also do that for you. And what you'll see if you do that is an automatic bump in accuracy. We've seen it all over the place.
Great. Thank you so much, Graham. And then Michael, there was one for you as well. If we were to use a cloud provider like GCP, how does that work with TigerGraph?
We have a couple of ways we can land. Well, first of all, let's kind of expand scope for a second and just say we can deploy anywhere. We can deploy on-prem or in the cloud. If your primary cloud provider is GCP, we actually show up in the marketplace through either TigerGraph Cloud, which is our managed service, or through a VM edition that you can just run on a specific instance inside the cloud. In the case of in the case of TigerGraph Cloud, as I say, that's a managed service. That means we take care of kind of operations, backup, and support. We also will kind of work with you to ensure that your queries and your applications, like Tiger Fraud, are deployed in the cloud seamlessly and securely. And so we love working with cloud providers to deliver great customer solutions.